Hey guys, Mr. Ground here, 8-2 part 1, trig ratios and solving sides. In this video, we're going to talk about solving sides. So when we're using trig to solve for a missing side length, this is kind of a quick example, right? Let's say that I've got a 90-degree, a right triangle. I know what one of the other angles is, and I have, let's say that the hypotenuse is 10, and I want to know what this side is, right? This is the type of problem that we're using. We're using this angle and this side to figure out the other side. There's some steps that we can go through that are going to be pretty much universal for these. The first step is we're going to label our sides, right? So in this case, 10 is my hypotenuse. I'm using this as my reference angle because I have an angle measurement there. I really can't use this one if there's no angle there. So I'm using this one. This is my reference angle. The opposite side is over here, and then the adjacent is here. All right, now which trig ratio I'm going to use, right? I want to use the trig ratio that has the sides that have the information, right? So I have information. I know what the hypotenuse is. I'm trying to find the opposite side. So the one side that I'm not really using here is the adjacent. Right? So I want the trig ratio that uses the opposite and the hypotenuse, and that would be so. So I'm using sine. Next, we're going to set up our ratio and we're going to solve. So I know it's sine, so I'm going to start out with sine. Sine of what? Sine of the angle, right? Sine of 30 degrees. So sine of 30. I like to put these over 1. Not all teachers do it this way, but I like to have it over 1. And that equals opposite over the hypotenuse, O over H. So x over 10. And once we get to that point, we can cross multiply it and solve. When we cross multiply, it's x times 1, which is just x. And then the other side is 10 times sine of 30. And now we can plug that into our calculator. We got to make sure we're in degree mode. And when we do that, we should come up with a side length of 5. All right, so some examples. Looking at this one, solving for x and rounding to the nearest hundredth. Okay, so I'm going to start out by labeling my sides. I've got my hypotenuse is 186. My opposite side is over here, and my adjacent side is where the x is. Now, which trig ratio am I going to use? Well, I have information here. I'm looking for this. I don't really care about the opposite in this case. So I want the trig ratio that uses a and h, and that is Ca, right? From SOHCAHTOA, that is C-A-H. And so that means that cosine of the angle, which is 30 degrees, is equal to our adjacent side x over 186, right? Now when I do this, I get 1 times x is just x, and the other side is 186 times cosine of 30. Now, I like to write it down this way where the number is in front and then it's cosine of the angle, because in the calculator, right, there's parentheses around that. And if you try to do cosine parenthesis 30, and then you put in times 186, and you don't put a parenthesis in there, it's going to screw it up. It's not going to give you what you want. You're asking for something different there. So this is really how we should do it. All right, from there, it's just making sure I'm in degree mode, and then 186 times cosine of 30. And I got to the nearest hundredth, 161.08. All right, let's do another one. Ooh, I like this one because the triangle is tipped onto its hypotenuse. All right, so looking at this, I want to start out labeling my sides. Right? The hypotenuse now is on the bottom. My opposite side, the angle, my reference angle 47 is in the lower left, so the upper right side must be my opposite. And then the 7, the remaining one, is my adjacent. Trig ratio. I've got the A, I'm looking for the O. I don't really care about the hypotenuse in this case. So which trig ratio uses O and A? That is TOA. So that means this is tangent 47 is equal to opposite over adjacent. And when I cross multiply, again, I get 1 times x, and I get 7 times tangent of 47. And I can just plug that in. And I've got 7.51. All right, another one. Now what I like about this one is there's going to be one little extra step to this. If you've been paying attention, you notice that it's always been like x over 7 or something like that, right? But what happens when x is in the denominator? That's why we don't want to skip steps with this, because it's easy to do. All right, so we're looking for side AB. So AB is here. I like to throw an X on there, so that's kind of my target. That's what I'm looking for. Then my hypotenuse, well, that's the X. My reference angle, 15 degrees, right? That's this one, angle B. And opposite of that is the 10.2, and then there's my adjacent. Which trig ratio? I'm looking for my hypotenuse. I have my opposite. Don't care about the adjacent, not using it. So which one uses O and H? So uses O and H. Sine of our angle, 15 over 1, is equal to opposite, 10.2, over the hypotenuse x. Right? So now when I cross multiply here, what's going to happen is on this side, it's x times sine of 15. So I'm going to do x sine 15. And again, I want to put that x in front of the sine. It just looks nicer. And then on the other side is 1 times 10.2. So now the x is here. Now what do I do? How do I get rid of this sine 15? Here's the thing with this. Sine 15 is just a number. So this is no different than if it was x times 5 equals 10.2. And I think most of us would look at this and say, okay, I'm going to divide both sides by 5 to solve this. It's the exact same thing. It's just that now instead of dividing by just a number, we're dividing by sine of 15. It is just a number. It just looks a little bit different. Sine of 15 is a really weird decimal number, and this is a really neat way of writing a weird decimal number. All right, so x times sine of 15, that cancels out. And what I'm left with, x is equal to whatever 10.2 divided by sine of 15 is. And that's how it would look if you're using the graphing calculator. Oops, snuck a plus sign in there. And so when I do that, I get that x is equal to 39, and we're going to the nearest hundredth, 0.41. All right, one more. I like this one because it's kind of an upside down triangle. Really forces us to think about which one is actually the opposite, the adjacent, and the hypotenuse. All right, so x is my hypotenuse. The reference angle is down here at 20 degrees. Opposite of the bottom is the top, so my opposite is up here, and that means that 3 is my adjacent. I have the adjacent. I'm looking for the hypotenuse. I don't care about the opposite. Which trig ratio uses A and H? Ca. And so cosine of 20 is equal to 3 over x. Right? Cross multiply, we get x. Cosine of 20 is equal to 3 times 1. And now to solve this, we just divide by cosine of 20. That cancels, and we get x equals 3 over cosine of 20. And I get that that is 3.19, like that.